Hello, let's do checkpoint 4.9. They want us to consider the region bounded by the curves y equals ln x and y is equal to e to the x in the interval from 1 to 2. So I'm assuming those are x values decomposed into smaller type 1 regions. Let's first draw the graph and see how it might look like. We have an ln function that looks something like this. It hits here at 1, and I suppose this could be 2 over here. And then the exponential function starts at 1, and then it goes and hits here at when x is equal to 1, this is e, and then it goes up, e squared goes pretty high up there. Let's just draw it up to here. Could be higher. Okay, and I suppose the other piece of information that we might want is this y value over here. This is ln of 2. I think it's 0.6 or something like that ish. And so if we bound this, let's call this y equals e to the x and y equals ln x. If we bound this from 1 to 2, then this is the region that we're looking at. So that seems pretty straightforward. Okay, they didn't ask us to do a type 1 region, but type 1 region would have been really super simple, because if we treat this as a type 1 region, we're going to draw a line parallel to the y-axis because we're going to integrate with respect to y first, and this is going to be y from ln x to y equals e to the x, and that's going to be our y limits, and then our x limits will be constants going from not 0 but 1, from 1 to 2, and then that's a fairly straightforward set of limits that we can just put in our integral. But in this particular checkpoint, they want us to decompose this into smaller type 2 regions. Now let's notice a couple of things. That if we integrate this with respect to y first, we would draw a line parallel to the y-axis. And if you're down here, parallel to the y-axis, you would be hitting a couple of functions, x functions. And what happens is that if you go a little bit higher, over here you will have this same function that you're hitting in this first part, but then instead of hitting the ln x function, you'll be hitting something different. So therein we have an issue in that we're going to need to, like they said, to decompose this into different smaller regions. Now, not only that, but if we draw a line up here, we're going to get yet another set of different functions. So to handle this in type 2 region, we're going to need 3 separate set of integrals. One integral will get cut off over here from the bottom part, so it'll be this integral here, and then we'll need to go a second set of integrals that would be dealing with this part, and then finally another set of integrals dealing with the top part. So these are going to be the smaller type 2 regions that we're going to look at. Let's first take a look at this bottom one. Now, a type 2 region is going to be integrated with respect to x first and then with respect to y last. So with respect to x first, we need to figure out what x value we're dealing with when we go into the region in the first place. So it looks like it's going to be a constant 1. It's a vertical line, so x is equal to 1 is your lower limit for the inner region. Now we need to be inside of this region until we hit this function going out. But you want that to be an x value function. So let's solve for x here. X is equal to e to the y. And so that's going to be your upper region, e to the y, or your upper limit. Okay, now the outer limits are constants, and the constant value for y goes from 0 to this constant value. Oops, I'm not going into the picture. Here is the y limits that we had put earlier. So this is going to be ln of 2, the constant limit of ln of 2. So this is going to go from 0 to the ln of 2. Okay, that's your first smaller region, the first smaller type 2 region. Okay, now that we've gotten that part, let's deal with this part, where if we integrate with respect to, well, one thing I want to note about this part is that this looks like it's a rectangular region. So whenever you have a rectangular region, you'll have constant limits. And what are the constant limits there? Again, type 2 region says we're going to integrate with respect to x first, and then with respect to y. And so with respect to x first, it's going to be an x value of 1 and an x value of 2. And then the y limits, the constant limits, are going to go from this lower y value to this upper y value. So this is ln of 2 and e to the first power. Okay, so that's your second integral. And then finally, for your third integral, it's this part over here. And we're going to, let's see, I think I need a different color, and we're going to draw a line parallel to the x-axis again. We're going to integrate with respect to x first, and then with respect to y. So the x limits are going to go, you're going to go into this function. X is equal to whatever this function is. This is y equals e to the x, and so you need to change that into x equals something, and this is going to change to ln y. So that's going to be the lower part of the limit, ln y, and then you're going to be inside of this region until you get out of this x is equal to value, and this is x is equal to 2. Okay, and then now your y limits, your y is going to go from this y value e to this y value e squared. So this is going to go from e to e squared. All right, these are definitely not nice looking limits of the partition, or the decomposition of this region, because you're going to have these strange functions. Not only that, but had we done it with a type 1 region, we would have been done with one integral. Now, if we were to decompose this into type 2 regions, we'll have to actually decompose it to 3 different regions to capture the same thing that we could do in one region. So I think this is a good exercise in figuring out how the region might look like, and how some ways it's a lot better to do it as one type versus another type. And it really depends on how your graph looks like. All right, I hope this helps.